Hello and welcome to Investigative Math. In this video, we're going to be talking about how you can qualify for state in UIL calculator. So the first step here, if you're completely new, is to just choose your calculator. So a lot of you probably have some experience with this. Maybe you did calculator in middle school and junior high. So you already have some calculators picked out. But in high school, the test is a little bit different. So you might want to adjust what you're doing. So my first recommendation, unless you're already really comfortable with a TI-84, in which case that's perfectly fine. These are the three calculators on the left. These are the three calculators that I would recommend switching to on the calculator test. And I mean, unless you're already really comfortable with like the 84, right? So we have the TI Inspire, we have the HP Prime, and we have the TI 89. So the thing that all of these calculators have in common is they have what's called a computer algebra system, which you can look into more on your own, but basically it just makes it easier to solve complex equations and just overall makes the process of solving problems more efficient. You have to do less by hand, and on calculator, whenever you only have 30 minutes to solve 70 problems, or 35 word and geometry problems, having to do as little by hand as possible is, it's pretty nice. So that's what I would recommend. Unless you're really comfortable with the TI-84 and you're strolling, you're cruising with the TI-84, these are the three. And then for the punch problems, um, some people are fast enough on these graphing calculators that they can just do the punch problems on the graphing calculator. In fact, the HP Prime is really popular for that because it has a reverse Polish notation, a reverse Polish setting. And if you don't know what that is, again, you can look it up. It's basically just a way of, it's like an engineering way of calculation where all your calculations are kind of done backwards. You can look into that on your own. But it sounds weird. If you've never heard of it, it kind of sounds weird, but it is pretty fast. So the HP Prime does have one of these. And so that's part of why the HP Prime is popular, because it has the computer algebra system and the RPN. Throughout my high school career, I personally used this calculator, the HP 35S. It has reverse Polish capabilities, and I personally just find it a little bit nicer. It really is just up to preference. So ideally, if you go to a school, if you can find like people that have these calculators and you can just like get a trial run of each of these kinds of calculators. I understand that not every school is going to have that kind of thing, but um, but yeah. So that's what I would recommend is get one of these three on the left for the word and geometry problems, or a TI-84. TI-84 doesn't have a computer algebra system, but it is still very good. And then for the punch problems, use either the HP Prime RPN if you're already using that for the stating geometries, and then the HP 35. Something I will say is sometimes these calculators can be pretty expensive. So what I would do as you're learning the calculator test, like if you're just starting out, um, what I would do is just use like the calculator that you've been using, like your TI-84 or whatever, to start learning the problems. And what I did is I like would place these calculators like in my Amazon wish list and just wait for them to go on sale. So like I know that right now the HP 35S it was discontinued, and so it's kind of expensive right now. It's like north of $200. But every once in a while you'll see it go on sale. Um, and sometimes it goes on a pretty significant sale. Like uh, when I was a freshman in high school, I didn't have my own TI Inspire, but I waited, and eventually it went to like 60% off, and I went and got it. So yeah, that's my spiel about calculators. Okay, so a few basic necessities before we keep going. First, you're going to have to know how to write and use scientific notation. If any of you have ever taken a science, like a high school level science class, you're probably already familiar with this, but it is still still a good thing to be like super comfortable with. Like going between normal notation and scientific notation should be like second nature. Second thing is significant figures. Besides like a couple of exceptions, on every problem on the calculator test, you're going to have to write your answer with three significant figures. It's not super difficult to figure out, but it is still something that you do need to know, because if you don't write it in three significant figures, then you'll just get it wrong. And then the third thing is just get used to your calculator, right? If you already have your calculator, like your school has a stash of TI Inspires or whatever. Just get an idea of like what your calculator can do. Like I've posted a series on like the big things that the TI Inspire can do, but like the TI Inspire has great graphing capabilities. This is not sponsored, by the way. I just happened to use this calculator in high school, and I really liked it. So like a lot of these calculators have things that you might not necessarily know that they have. For example, I know that the Inspire has a conversion assistant that can help. Like if you forget, like, oh, how many milliliters are in a cup, right? That's like between two different systems of measurement, so it may be pretty difficult to remember. Well, the TI Inspire has a way that you can convert between these two things relatively quickly. Of course, ideally, you would have all these memorized for speed. But my point is that sometimes you'll come across a question on the calculator test that you don't know how to do, but because you know a certain thing the calculator can do, um, it makes the problem solvable. Okay, the next part is just the parts of the test. So if you're if you're new to calculator, keep watching. If you've done calculator before, then you can probably skip this. This is some pretty trivial stuff. So the parts of the test, you have the number crunchers, the punch problems, which are basically just you're um, trying to see how many of these just straight calculations, right? There's no like problem solving involved. It's just straight calculations, and that's what you would be using either the reverse Polish on the HP prime or the HP 35 for. Yeah, and those are just like straight calculations, no problem solving required. And then you have, and that's 35 problems on the test. Out of the 70, that's 35 problems. So it's a pretty decent chunk. And then for the geometry, um, every page on the test has two geometry problems, and they range. They range from things as easy as finding the area of a circle to finding like the solid of revolution and like more advanced plane geometry problems like on the backside. And then you have your stated and word problems. And there's three of these on every page. There's 7 pages, by the way. Three of these on every page for a total of 21. 14 geometries, 21 stated problems. And these are pretty varied as well. Like on the front page, you'll have like really basically punch problem sort of worded geometries like what is the square root of 21 times 31, like 21 times 39. Like maybe that'll be a stated problem, but it'll just like write it out in words. And then on the back, you'll have like overflow problems and projectile motion and that kind of stuff. So these are all pretty varied, but the point is that every page will have 5 crunchers, 2 geometries, and 3 stated problems. So that's kind of just how the test is set up. All right, we're gonna start breaking this down a little bit. So how do you get faster at crunchers? So this the first part of this is kind of what I was talking about earlier, the basic necessities. Get used to your calculator. That includes the calculator that you're punching with. So just getting down like some basic muscle memory on your calculator will help you a lot because you're not having to look back and forth for every single number. You can start going on autopilot just a little bit, and this will also help you with something that I'll talk about a little later. So the first thing, once you've actually like learned how to type in reverse Polish or whatever, is you're always gonna want to type on the table. And I know for those of you that have been to a calculator competition or UIL contest, you're kind of chuckling to yourself right now because there's always the one guy that has their calculator and they hold it like they're texting on their phone. And the worst part is that after each question, they like really loudly set it back on the ground or on the table. And yeah, it can get a little bit annoying. So yeah, that's the main thing is type on the table. And the other thing about typing on the table is that instead of just using your thumbs like you would if you were texting, you can use like 4 fingers. I usually type with like my pointer middle finger on each hand, maybe like pointer middle on my right hand and then like pointer on my left hand. Um, but yeah, it really just depends on you. But whatever you do, typing on the table will always be faster. And then let's see. Oh yes, you're always going to want to place your calculator below the problem that you're solving. And what this does is that whenever you're looking back and forth, solving a problem, you're not having to relocate the problem each time. So what I mean by that is like if you have your calculator over to the side, like there's a lot of numbers. Like within 5 crunchers, especially whenever you get to like the fourth and fifth page, there are fourth, fifth, sixth page, there are a lot of numbers on each page. Just because the crunchers are longer. So if you're not having to like relocate the problem each time, you just know, oh, this problem is always going to be directly above my calculator. It does save you a bit of time. And by a bit each problem, which times 35 ends up saving a while. The other thing I would say is try to figure out a way to hold your pencil while you're typing. Once again, you know, it may not seem like picking up your pencil, writing, setting it back down for each problem would take that long, but if you compound it over the course of 35 problems, um, it all of a sudden becomes pretty significant. Like you can end up using it like a whole extra minute, minute and a half, 2 minutes, just like picking your pencil back up. And it also takes you some time to like get reoriented with your calculator. So just these little things can really add up over the course of the whole test. And then the last thing for this isn't really like how to get faster other than just practicing, but I will link a punch packet with just a whole bunch of number crunchers in the description for you to practice on your own. Okay, so here's a little bit about the structure. We're gonna start talking about geometry and word problems now. So here's a bit of the structure, and now I'm looking at this and I realized I've left off page 7, but that's okay. I'll still talk through it. So on the left we have the geometries, and on the right we have our stated problems. And the reason I show you this is because there actually is a structure to this test, which makes it one of the easier tests to study for, right? Like for geometry 9 and 10, simple one-step non-triangular shapes, right? I mean, there's only so many formulas for one-dimensional shapes, right? You got like circles, trapezoids, squares, rectangles. Um, you can also have like more creative shapes, like you can have half and quarter circles, that kind of stuff. You'll see that more on like later tests, like maybe regional tests. And then 1920, like if you know how to use sine, cosine, tangent for right triangles, then boom, now you can do 19 and 20. And Pythagorean theorem, now you can do 19 and 20. My point is that whenever you're practicing, it's very easy to target specific questions if you know the structure. So let's look. So 9 and 10 is simple one-step non-triangular shapes. 19 and 20 are right triangles. 29 and 30 are simple one-step solid geometry. So that might be something like you have the volume of a cube, and you want to find like the diagonal between like the two corners. Or something like you have the surface area of a sphere and you want to find the radius. And then page 4, number 39 will be triangles with inscribed or circumscribed circles. And then 40 is law of sines and or law of cosines. This can also be like compound triangles. So you'll see like multiple triangles put together. And you have to solve for the different lengths and figure out those relationships. Page 5, medium solid geometry. So very common problem you'll see on here are like frustums and just like more difficult variations that you'll see on page 3. Number 59, you have calculus. That's a lot of your solid of revolution and sometimes just like area under a curve, right? Sometimes it's not even geometry. It's just completely calculus. Number 60 is difficult plane geometry, and in fact 64 and 65 are also difficult plane geometry. So like 60, 64, and 65 are like the wild card questions on the geometry because they're kind of hard to predict. I will talk about this a little bit later, but yeah, they are a little bit hard to predict. They're meant to be the hard questions. They're meant to be like for those people that are scoring in the 300s or like high, like 280s, 290s to help differentiate between like first place and second place, like who can solve the most problems that they've just like never encountered before. And then on for the word problems, 6 to 8, you're going to be like these easy general problems, right? Some you might have just like a basic arithmetic calculation. Sometimes it'll be like, if you purchase this thing with this amount of tax, how much does it cost in the end? Or like how much change would you get if you used a $100 bill? That kind of problem. 16 to 18, medium general problems. And in fact, 26, 28 is medium general problems. These are very diverse. So I would say that the geometry is definitely a lot more specific than the word problems. But as you're looking through these, you'll start to recognize patterns. So a lot of times in these questions, you'll see things like distance, rate, and time problems, like working together problems, percent change, um, that kind of thing. And then 36, 38, these hard general problems. A lot of times, uh, at least one of these are actually pretty easy. You'll see things like clock angle problems just that are just pretty easy, if you know how to do it, of course, or quick. I should say it's pretty quick if you know how to do it. And then yeah, like I was saying, usually one of them is really easy, and the two others, usually there's one that's like pretty abstract that you haven't really seen before, and one of them is usually some sort of like geometric modeling. What I mean by that is they might give you like some sort of realistic problem. So like a good example is like you have like a dog tied to like a fence post, and you want to find like the roaming area that dog can go to. So it's not a geometry problem, but you have to model the situation as if it was a geometry problem. So that's a pretty common thing. 46, 47, 48 are all on the same page, and it's nice because you always know what they're going to ask. So 46 is scaling. You'll oftentimes see this as like, let's say they tell you the height and weight of the Eiffel Tower, and then you want to find like the weight of a scale model if the scale model is like 1/100th of the height of the Eiffel Tower, that kind of thing. Best fit lines, they'll usually give you some sort of like a data set, and then another part, and then say they'll give you another point, and you have to figure out like what the y value is there. So basically, like interpolation for best fit lines, and a lot of these calculators can do this very well. And then 48 is arguably the easiest question on the test, as long as you can get to it. It's just the solver. So like almost all of these I think all the calculators that I mentioned, besides HP35, have a solver. In fact, even the HP35 has a decent solver. It's just not as good as the computer algebra systems. Yeah, and so that's a solver. You can also like graph those and just find the zeros. So 48 is a pretty easy problem. 56, calculus basics. A lot of times this will be like just your basic derivatives. 57 is a pretty infamous question. 57 is oftentimes the most difficult problem on the test, especially at the later levels. It talks about stuff like related rates and like integral calculus, that kind of thing. That might be a better label for this. 56 is usually some sort of differential calculus, and 57 is usually some kind of integral calculus / related rates. That's probably how I would describe it. But 57 is just like it's like modeling real world problems with calculus is probably the best way I can describe it. And then 58 is matrices, and you just have to know some basic matrix algebra. 58 is usually for a lot of people, that's the last question they answer because they know they can answer 58 because it's generally like there's not a whole lot of variation with matrices. And then these aren't on this list, but as you keep going, number 61, 62, 63 on the back page are also word problems. 61 is another one of those just hard general problems, right? You never really know what's going to come up on there. Sometimes it's super easy, sometimes it's really hard. There doesn't really ever seem to be an in-between. 62 is what we call an overflow problem, where it's basically just like an exponentiation problem. But the thing is that it usually goes above the memory capacity or the calculation capacity of your calculator. And so whenever you type it in, it'll say like infinity or overflow. And you have to use like log properties in order to solve those. And then finally, 63 is just projectile motion like you would see in an introductory physics class. Yeah, so that's the structure for the word and geometry problems. All right, now for practicing geometry. Here's what I would say I would say for the easier problems, figure out the ideal strategies to save time on these. So like, what I mean by that is a very common thing you'll see uh, whenever you give students a computer algebra system is they'll start to like abuse the solver a little bit. And a good example of this is with like the right triangle trigonometry. You'll have a basic thing like sine theta or like sine 27 equals x over 1200. Which of course, like if these students have taken algebra 1, which if they're in high school, I'm assuming that they have. If these students have taken algebra 1, like they can definitely just do this normally. But now they have this solver and they feel like they have to type everything in the solver, um, like to have that level of security. But it ends up wasting them a lot of time. So figuring out which problems do you really have to use the solver for, like which problems is it faster to use a solver. You might be able to find out shortcuts for like variations of problems that they'll ask sometimes. I don't have an example of that off the top of my head, but like as you do like practice problems, it'll become more apparent. The second part is do high speed on the problems. High speed on these problems are the key to having time later in the test. So yeah, that's kind of what I was saying. So making sure you can do the area of a circle, like that in like 5 seconds. If that's on the front page, that's super good because like every problem is worth the same amount of points, right? The hardest problem is worth 5 points, and the area of the circle is also worth 5 points. So if you can do these super easy ones super fast, right, then you're gonna have more time on average to solve the more difficult problems. And this is what I like to practice whenever I had like a low motivation day, whenever I didn't really feel like practicing calculator. Maybe there was like a rough day at school or something. Uh, just practicing the questions that you know are super easy. Just trying to get them faster and faster, so later on you'll have more time to do the harder problems. And then finally, there's going to be some that you really just have to learn, like that you haven't learned just from school. So a lot of like the law of sines and cosines, maybe the variations are harder than what you've seen in um, like just in school. And so what I would recommend is in the description, I'm going to link like a geometry and stated in geometry workbook for you to go through. And in fact, I was talking before about like 60, 64, and 65 as being like the hard geometries. Some of these problems in this workbook, the 60, 64, 65, some of the problems in these workbook, I've seen directly repeated on modern tests. Like at the regional test this past year, um, if you're seeing this more than a year from now, the regional test from 2023, they were out of the 60, 64, and 65. Two of those problems were directly quoted from previous tests that were written in this practice book. And in fact, we won region that year by only our team won region that year by only 2 problems. So going through that workbook, um, just like it made us win. I mean, like it took a lot of practice before, but that was like the little extra boost. Like solving difficult problems is difficult, but if you've already seen them before and you've solved them in like non-pressure situations, then it can really help you. So I would highly recommend if you're, especially even if you're already really competitive and you're like just looking, maybe you qualified for state and you're looking to win state, going through this packet, you'll start realizing like, wait, I've seen this problem like on last year's test. Like, why in the world is this in here? And it's because that's the material that he uses. Okay, now for word problems. Um, Besides like the easy ones at the beginning, word problems are generally what I would consider the hardest problems on the test because it's a little bit more difficult to figure out what they're asking. Like in geometry, it's very, very specific. Like you want this side length? Well, I'm just gonna point to this side length. And sometimes it's a little bit more difficult to interpret these word problems. What I would recommend though is start identifying, like create a list of the kind of word problems that you'll see. So really common ones are, well, like the ones that are on every test, like scaling, linear regression, the solver, projectile motion, overflow, that kind of stuff. Like those are on every single test. And then start like making a list of the other common ones that repeat. So I'm thinking like working together problems, distance, rate, and time problems, percent change problems, all that kind of stuff, and just practice those because those come up very, very frequently. And then once you have a good handle on those, you can move on to the more variable problems. And then a good way, once you feel like you're pretty comfortable with these questions, a good way to test your understanding is to take like a previous problem, and try to like change it a little bit. So a pretty common example that I would use when teaching is, for example, like going back to that Eiffel Tower example. So maybe you're making a 1 to 100 scale model of the Eiffel Tower, but maybe, and you're trying to find like the weight of the scale model. Um, but maybe the material you're making your scale model out of isn't the same as the material the Eiffel Tower is made out of, right? So maybe instead of using, I actually don't know what the Eiffel Tower is made of, but I'll just say it's metal. I don't know what kind of metal, but it's probably metal. Let's say instead of metal, your scale model is made out of plastic. Well, um, you could figure out what's the density of plastic versus what's the density of the metal in the Eiffel Tower. And on a real test, they would give you these numbers, obviously, and then try to figure out what the weight would be. So, kind of like adding these variables really make sure that you have the ability to manipulate these ideas in your brain in new ways, and this will also help you avoid getting like blindsided by curveball questions at state because he does like to like mix it up at state. You'll rarely see like a super straightforward problem. It'll usually be some variation of a past problem that he's asked, just with a little bit more creativity infused, and that's when these practices really help. Okay, now we're going to talk about some of the state qualifying scores. So I know not everyone watching this video will have this goal of qualifying for state. Some people are like, oh, I just want to make my school's team. I just want to qualify for region. And then some people are going to be like, forget qualifying for state. I want to win state, right? And like, that's all for you. But this is a very common goal, so I figured I would talk about it. On the right, you have the average third place score at a region, and the reason I bring that up is because third place is the score that you need to qualify for state from the regional level. Of course, you can also qualify with your team, but that's a separate thing. So yeah, so you see 1A through 4A, you're in like the high 100s slash low 200s, and then going to 5A 6A, you start creeping up into the high 200s, like the 273, 272. It's very interesting that that was that close this year. It's usually not that much. Um, I will say the calculator is a very freshman friendly contest, and freshmen place in the top six at state all the time. Like even just last year, shout out Brennan Ashley from Hallsville. Gave me a run for my money at state last year. He made a 318 and placed second at the 5A meet. Yeah, kind of just came out of nowhere. But calculator, if you have like a promising freshman, he's not sure or she's not sure whether or not they want to do number sense calculator or math, tell him like calculator is a really good one to get into because one, um, you start getting acquainted with your calculator, which will help you a lot more if you decide to do math in the future, and also a little bit of like the mental agility that you have to have with calculator will also help you in number sense. Like you're not going to learn any number sense tricks doing calculator, but it does help you get used to like the time pressure if they decide to do number sense later. I was going to say something else, and now I'm struggling. Oh yes, yes. Um, so I said that these were averages, right? 188, 225. Like these are averages, and these can be a little bit misleading because some regions are obviously stronger than others. For example, like in my region last year in 5A Region 1, last year being 2023, the third place score, right, the score that was needed to qualify for state was a 301, right? It was over 300. It was kind of ridiculous. In fact, I'm pretty sure sixth place was like a 287 or something like that. Um, it was a really competitive meet. You had Wiley, which is my team, you had Lubbock High and Argyle all in the same region. And yeah, so some regions are just very, very competitive, and then some regions just aren't. I mean, a lot of times it's because in 5A, the non-competitive regions, it's usually because most of those schools are 6A, and so you'll see that in 6A. Like the schools that maybe would be good in 5A are just like smaller 6A schools that are competing in 6A. So yeah, I would recommend looking into your region's scores, but this is just to give you like a ballpark, show you like the divide between like small school and large schools. Okay, the next thing. So now that I've showed you kind of the goal scores that you want to be going for, right? Like pretty much like in the 200s range, will get you to state on average. We're going to look at some test taking strategies to help you maximize your score. So looking at this table on the side, you see that even if we use the 1A qualifying score of 188, so that's somewhere in here between the 185 and 206, um, you're going to want to work all of the number crunchers, which may seem a little bit scary because you are skipping a lot of problems. You're skipping a lot of problems, But I just want you to, for right now, just trust me that this is the best way. Um, as you do these, you will get faster. You'll be able to come back and answer more stated and geometry problems. But for right now, you just need to be able to go through the whole test and answer all of the number crunchers. That's kind of like an introductory strategy. As you get like more advanced, like you can start maybe answering 6, 7, 8, 9, 10. Like maybe you crunch the first page and then do all the stated geometry on the first page, and then you'll crunch to the end. Or maybe you'll be crunching and then you'll answer like number 48 because that's the solver problem. Because it doesn't really throw you off your rhythm. But like if this is sounding too complicated for now, just starting off, just work crunchers and then come back if you have time. Uh, the ideal speed that I would say for crunching all the way through your state and geometry problems is around 10 minutes. If you can get it down to 10 minutes, that's a really good speed. Um, that's about the speed that I'll see like the people at state crunching in 5A. I'll see the people at state crunching in around 10 minutes. But of course, it does vary because some of those people don't just crunch all the way through the test. If you can, I would recommend getting it down to at least 13 or 14 minutes before you start going like pretty hard into like the stated and geometry practice. So so at the beginning, your calculator practice is going to be kind of boring, right? You're just going to be trying to get that time down to like 13 or 14 minutes. But the thing is that this will allow you to start being able to solve the stated geometries, right? Like there's no point in there's no point in practicing the stated geometry if your crunchers aren't fast enough to get to them, you know. So the next point is like I said, the way you go through a test depends on how you can how quickly you can do the stated and geometry problems. So like if you come across a stated and geometry problem, um, and you're looking at it and you're like, oh, I can do that. I can do that super quickly. It's not going to throw up my rhythm. It's basically a cruncher because in my brain I'm knowing like exactly the steps that I have to take. Um, a lot of times for people this will just be the geometry problems because there's not reading and like you can just see the picture and know. Like number 9 and 10 maybe it'll be like a circle and a rectangle, and you look at it and you don't really have to like. There's not really any problem solving required. Like you kind of just look at it and like the entire problem is kind of just spelled out in front of you. And then you'll also have like on 19 and 20, it'll just be like a SOHCAHTOA problem and a Pythagorean theorem problem. Most people can, if you have experience, of course, most people will just be able to look at that and say, oh, I need to use sine or cosine or tangent, and then this is Pythagorean theorem, right? Not difficult at all. But the point is that if you're quick enough at it, it doesn't throw off your rhythm for your crunchers, and so you can just keep going through. And like my strategy at state was all over the place, right? Like once you once you start doing this for a while, it becomes a little bit more nuanced, where you can where you can look at a problem and kind of judge how difficult it's going to be, how much time it's going to take. So I didn't really have like a set strategy, excuse me, a set strategy going into state. It was more just like if I read a problem and it looks like I can do it really quickly, then I'll go ahead and do it. If it looks like I can do it, but it's gonna take a bit, then I go ahead and skip it and come back to it after my crunchers because I don't want it to throw off my rhythm. Especially if you run into a problem when you're crunching and you try to solve it and you can't solve it, that's gonna like affect your confidence. It's gonna mess up your speed. So really, like as you get better, you should be crunching through the test and just like knocking out all the super easy ones that you know you can get. Okay. Okay, now for a little note on programs. So there's a lot of opinions on programs. What I would recommend is you use them for like really common problems. So problems like solid of revolution, frustum surface area, like frustum volume. Like there are formulas you can remember, but sometimes they can be a little bit tedious. The shoelace theorem is another one. You'll see shoelace theorem on calculator. Um, it's in a little bit of a weird place. So I actually encourage you to go and look on like 64, 65 problems and see if you can figure out how you can use shoelace theorem to do some of those problems pretty quickly. It's kind of a fun puzzle. Um, and then one for triangle solvers. You don't always need this for like sine and cosine, but sometimes for the like inscribed circle, circumscribed circle problems, these can save you a lot of time. Um, but my recommendation, especially if you're a coach watching this, is don't give your students programs for problems that they can't solve without the programs. Because this is how you get into trouble. Because especially at regional meets, he's really going to test to see if you know your stuff. Like 2 years ago at the 2022 regional meet, I think that there was a problem that it was just like an equilateral triangle, and then there was a circumscribed circle around it, which is an easy enough problem, right? But the thing is that he gave the radius of the circumscribed circle, and you needed to find the area of the triangle. And most programs, because this is what he usually asks, right? Most programs will take the three side lengths and then give you the radius, right? And so in fact, this was a very easy problem, but if you had only ever used the program before, it's a really easy way that he can just like trip up like hundreds of students across the state, right? And so don't be using programs unless you can solve it the regular way. That's what I would recommend. So programs, like, they're not evil, right? They're not evil. Some people will tell you that like programs is like against the spirit of the contest. Well, it's like, well, if you can program your calculator, it is the calculator contest, right? I used programs in high school and I turned out fine, right? um, but yeah, don't use programs for things that you don't know how to do, because you'll end up regretting it. Just trust me. All right, so some conclusions. So speed and accuracy really just comes down to solving lots of problems, right? You're never going to get faster just by looking at solutions and being like, oh, I could do that, right? Because, the truth is that if you could do that, then you would have just solved it the first time around, right? You do need the practice of solving the problems on your own without like the safety net, and then going back and looking at the problems. My next thing is focus. Now, if you watch my number sense video, I did talk about focus in a pretty good amount of depth. And what I would say for calculator is that focus isn't as important, because you're not having to do all these things in your head. Like, your calculator is doing most of the heavy lifting for you. You're basically just having to solve the problem, and then the calculator kind of does all the calculation. And on number sense, the place that people make the mistakes is not in how do I solve the problem, it's in the actual calculation. So focus on calculator is important. I will say that whenever you're crunching, people will sometimes just zone out, and they'll just like they'll get in the zone, but what they're really doing, they'll think they're in the zone, but what they're really doing is zoning out. And that's whenever you'll miss crunchers. And like I said, crunchers are worth the same amount as data in geometry. And so you want to miss as few crunchers as possible. If you're missing more than one per test, that's a pretty good indicator that you need to go and practice these. And then finally, whenever you're practicing on your own, just be honest with yourself about what you need to work on. Like, some days you'll have low motivation days, and like we talked about that earlier. But like, if you're really good at like solver problems, like number 48 solver problems, and you've taken tests throughout the year and you haven't missed them, like, you probably don't need to practice them. So just be very vigilant, be very aware of what problems you have difficulty solving, and practice these. It's not going to be as much fun practicing, because you're not going to be able to solve as many, and it'll be a little bit hard and tedious. But it will feel good later on whenever you're at a contest and you're able to solve this problem that you've put a lot of time into. And and really, if you're practicing for an hour, but you only practice the things that you're already really good at, then like, where did that practicing really go into, right? Maybe you got like incrementally faster, uh, but the vast majority of the time you're going to be wanting to practice things that you either don't know how to do. The other part is don't know how to do, or you are pretty slow at doing. Okay, so that's about all I have. I'm going to link those practice packets in the description, along with like a beginner formula sheet that I've put together, like conversion sheet, formula sheet that I've put together. So if you have any questions, make sure to leave a comment, and I'll try to get back to you as soon as I can. If you like this kind of thing, I will try to come out with a math video in the coming weeks, relatively soon, and I hope that can be pretty good. But if you have any questions, feel like I didn't cover something very well, or just want me to like expand more on something, leave a comment. Um, be sure to like and subscribe because these videos do take a little bit of time to make, and I'm a busy college student with like other stuff to do. I love doing this, but it does take a bit of time, so I would appreciate it. So, with that being said, this has been Investigative Math, and I will see you next time.